Yes. So this is program 1 for aim 1, and this program is simply to print a character which is being stored in the register AL. As I have told already, uh, the int 10h is being used with the argument of AH is 0E in hexadecimal. So the first line stores the character to be displayed in AL. The second instructions is a constant argument constant to AH, and I'm just calling the function subroutine. So calling the subroutine by this manner is called simply a software interrupt. That's it. So once I finish this, automatically what happened? The character, whatever the ASCII equivalent of any character comes in AL, it is being displayed. Then next, I change the another value to AL, that is ASCII of B to AL. One more time, I am running it. Here, one more time, you no need to do this because already AH is in E0E, so you no need to worry about it. After that, I just halt it. Look at how this program is running. So what happens? So whenever you go for emulations, the program runs once, and again you have to reload it and run it. You can see it now. So the registers, in the display unit, the value AB has come. You can give anything. You can give anything. So any numbers, even if you want to print some number, this number. So compile it and run it. You can see it. A9 something is being coming because A first and A9. You can keep display so many characters one by one, and you can print as a whole the string. That is what the programs in that's what the program in aim 1, and program 2 of aim 1 is to display the string. So I just go to the program, something like this. You have here how to display a string, right? So here is not a string. To display a string, here you can see the same interrupt is being used. What I have done, this program will display something like this. So what I do, I initialize the pointer to the registers SI and DS, and I bring the first character to AL. This no, you are familiar with this instruction already. And I'm comparing. If the AL value is 0, generally in this memory I store only ASCII equivalent, and the value 0 of the value 0 is null character of the ASCII equivalent of the null character. That is what I check for null character. If null character comes, I stop for executions. So stop. Otherwise, I proceed for printing it. So once I print it, I increment the pointer, then I go for printing the next character. I keep doing this. Still, if the memory contains the value 0, it doesn't equivalent to any of the characters. 0 is null character. That is what. So we just run this program. Look at the alignment. Here alignment is not good, and you need to make it to proper. So here nothing is coming because I have not given any value, but it has run already once. So go here, go to memory, and change the go for giving the value. I'm giving some value straight away. Here 41 is an ASCII of character A, 43 an ASCII of character C, 45, 46. Some enemy character you can give. 31 is an ASCII of the number 1, 32 is number 2. That's it. So thereafter the 0. So 0 meaning that it is null character. Fine. Good. So now again I go for reload it and I run once. You can see now I have stored 414345563132 as the ASCII equivalent of the character ACEB12. So you can see here this program is for what? printing a string, but the string is in external data segment whose offset address is in, the offset address is 1000 and base address is 8000. So that is what the way of printing a string. And you go for the example program here. Here you have the program called hello. This program will help you that how to print a string which is in code segment. The string is this. So what you do, you go through with the program and read the comments being given in the program itself. This program we have not written. It comes with the software itself, and you just go through with the statement and comments and instructions and all given in this, and you try to execute by yourself. When you come to the lab, you need to give some other string in some other address space of the code segment, and you need to make us to clear how you understood this program and how can you modify the programs in whatever extent of the question being asked. And second, we go for how to read a keyboard. Yeah, this interrupt used to read a character from the standard input, keyboard, as well as when you hit the key, the hidden key value comes to AL register. As well, you can see it in the display itself. And the idea is, you need to give the argument of AH register to 1 and run int to 1h. This function will wait till you press any key. So once if you run the program and if you don't press any key, the program will not come out from these functions. You are in the execution still waiting for any key to press. So whenever you use this kind of interrupts, you need to know some of the key need to be pressed and that key value being stored in AL. So that is an idea. We go for some sample programs to understand the value of understand the keyboard. So here what they have done, let me wait for, see here this program, I just invoke the software interrupts, then I halt it, that's it. What happened, this function waits for the input, keyboard input, and the pressed key value being stored in AL register. Here AH register is a constant and it is an argument to that function int to 1h, correct? I just go for emulations, I run it. Look at here, this is your display device. It waits for your keyboard input. Now I am going to press the character A, capital A, and what happened, look at the value comes to AL. Already AH is 1, right? You know it. I press A. Now I pressed, pressed value has come to screen. I told you, it is an echo, but originally the pressed value goes to AL register. You can see here the AL register, the result comes. The same program I do a little bit change, you wait it, I do jump. So again I put here, so every time I no need to initialize AH. If you do it again, nothing wrong, but basically it's a constant, right? And while same value being, you no need to write it again and again. So I go for compilations, then I just for running it waiting, it is running already. It waits for the input. I just press capital S. You can see here this is an ASCII value of the capital S, and I press capital A, but now the AL value becomes changed. But here you can see the value A. But every time you keep typing, giving some input data, the AL register value is being updated only in AL. But anyway, so now you can see it. So what you do, so every time when you run this, whatever you type here, the value being updated to AL, you need to write it back to a memory space. Allocate 10 memory ranges from 8000:1000h to 1009. So as the key pressed one by one, you keep update the memory one by one. When it reaches to 1009, so I just go here, you updated the input data from this memory 10029. So when all the data have been stored one by one, when it exceeds become same, meaning that your memory space is being overflow, then you write back the same, I mean the next keystroke here. So what happened, the first keyboard, I mean key pressed, is discarded and it is being updated in the new memory. So in any case of time, always the last 10 keys pressed is being stored in the memory. But look at here, when you update, when right now you are in this 1002, this is what your the current key pressed. Before that 1, before that 0, before that the key was, I mean pressed, and the key pressed was in 9. After that, I mean before to that the key pressed was in 8, something like that. So you need to understand in such a way. This is the way of I mean the way of accessing the memory is called circular buffer. Circular buffer or circular memory, that's it. And similar sense, you need to understand all other programs, and you will be doing any programs related to input output, and you need to do it. And in case of any clarification, you can discuss with me.